Hello, in this video, we're going to be looking at lesson 4.1, and we're going to talk about congruent figures today. Our learning target is to determine if two figures are congruent. So let's start by defining what it means to be congruent figures. Congruent polygons are polygons that have congruent corresponding parts. And by corresponding parts, we mean the corresponding sides and the corresponding angles are congruent. This picture here is an example of two triangles that are congruent. Remember that in diagrams, congruent parts are marked with the same marking. Now you can name the first triangle however you want. So I'm gonna just name the first triangle, triangle DEF. But then when we name the second triangle, we have to name it in the same order so that our corresponding parts match up. So notice that angle D here has 3 arcs. D matches with G. So if D is my first letter here, G needs to be my first letter in its congruent triangle. Then we have E. Well, E has 1 arc, and you can see that matches with H. And then I would come last. It matches with the F. Now that's one way to name the congruent figures. I could have gone in a different order too, just as long as we match up congruent corresponding parts. So as another example, let's suppose that we name the first triangle, triangle EFD. Now I would start, E has 1 arc, so E would have to go with the other with 1 arc, H. And then F has 2 arcs, that matches with I, and then G. Both of those are correct, and there are many other ways we could write it too. We just have to make sure that we match up our corresponding congruent parts. Okay, the other theorem that we're gonna learn in this section is the third angle theorem. In the previous unit, we learned that in any triangle, the 3 angles always add to 180. And that idea actually leads us to the third angle theorem. The third angle theorem states that if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. In our diagram here, angle A and angle D are congruent to each other. And angle B and angle E are congruent to each other. So by the third angles theorem, we would be able to conclude that angle C is congruent to angle F. Now let's try our first example. Here we're given triangle ABC is congruent to triangle QTJ, and we want to list the congruent corresponding parts. Now when you list the congruent corresponding parts, you're going to have angles, and you're going to have sides. 3 angles and 3 sides. Let's start with the angles. Notice that angle A is the first letter here. Well, angle A and angle Q match up. So we're able to state that angle A is congruent to angle Q because they are in the same position in our congruence statement. Next, let's do angle B. Notice that angle B is the second letter. Well, that matches with angle T. So angle B is congruent to angle T. If we want to mark that in our diagram, we would want to use 2 arcs to show that B and T match up, but they're not going to be the same as A and Q. And then for our last angle, we would have angle C congruent to angle J. And I'm going to use 3 arc marks. There we go. So now we have our 3 pairs of corresponding angles. Let's move on to the sides. The sides are a little bit more tricky because you do need 2 letters for your sides. Let's start with side AB. So side AB in the first triangle is the first 2 letters. AB matches with QT. And if we want to mark that in our picture, we use tick marks to mark the sides congruent. Next, I'm going to go with side BC, so the middle letter and the last letter. And notice that BC matches with TJ. So BC and TJ. And then our last side would be AC, kind of first letter, last letter. So AC, and that matches with QJ. So there is my list of all 6 congruent corresponding parts. We have 3 sets of congruent angles and 3 sets of congruent sides. We could have done this too, even if we didn't have the picture, just by using this congruent statement. And that's what you're gonna do in the try now next. For the try now, I want you to list out the 3 pairs of congruent corresponding angles and the 3 pairs of congruent corresponding sides. Please pause your video now, and then when you hit play, you can check your answers. Please pause. All right, here is your solution. We should have 3 pairs of congruent corresponding angles. Remember, they're just in the same spot. So first letter here, first letter there, WM, Y and K, and S and V. For sides, you do need the 2 letters. So I used WY and MK first. Then I did YS and KV second. And then last, I did the WS and the MV. In this next example, we're going to use the congruent statement to help us find the measure of angle X. We're given triangle XYZ is congruent to triangle KLM. We're also given that angle Y is 67 degrees and angle M is 48 degrees. Now, let's match up the congruent corresponding parts. If Y is 67 degrees, L also has to be 67 degrees. And if M is 48, the last letter, Z must also be 48. So there we already have 2 out of the 3 angles in the triangle. Now, if it helps, you could make a visual of this if you want. So I'm looking for the measure of angle X. So I have a triangle here. I'm probably not going to make my triangle necessarily to scale here, but let's just go with it. So I have X, Y, and Z. Angle Y is 67 degrees, and angle Z is 48 degrees. Now we need angle X. Well, angle X is the 3rd angle in the triangle, and we remember from a previous lesson that the 3 angles in the triangle have to add to 180 degrees. So we would have the measure of angle X, whatever that is, plus 67 plus 48 adds to 180. The total sum, the triangle angle sum theorem says that the 3 angles, the 3 interior angles, always add to 180 for any triangle. Let's add together the 2 that we know here. 67 and 48 is 115. And now, measure of angle X plus 115 has to equal 180. We can then just subtract 115 from each side. So the measure of angle X must be 65 degrees. That way now the 3 angles, if you add them up, you check your answer, they do add to 180 degrees. Next, we're going to try to decide if we have enough information here to conclude that triangle ABC is congruent to triangle EDC. In order to do this, we need to make sure that our congruent parts match up. So we need to check, do I have 3 pairs of congruent angles and 3 pairs of congruent sides? Well, let's check here. For angles, I can see angle A is congruent to angle E because it's marked in the diagram, so it's given. A, E. We can see that angle B is congruent to angle D because those are both 90 degrees. And then now that we have 2 pairs of congruent angles, we can get the last pair right here. either by using vertical angles or using the third angle theorem. It really doesn't matter. So those are congruent. They're either vertical angles or that. Now, I don't want to call them both angle C, so I'm going to use 3 letters on that. Let's say angle BCA is congruent to angle DCE because they're vertical angles. So we're good on the angles. Now let's check our sides. For the sides, side AB is 3, and that should match with side ED. So side AB equals side ED because they're both 3. And then let's check another side. How about side BC and side DC? BC and DC are both 4. So we have BC equals DC because they're both 4. And then lastly, we have side AC. And notice that side AC has a tick mark on it, and so does side EC. So that would be because they're marked congruent. It's given in the diagram. Just like this one was marked. And then the B and D, they're both marked. But the reason they're congruent is because they're both right angles. They're both 90 degrees. So now I've shown that all 3 angles are congruent and all 3 sides are congruent. So that tells us that the triangles are congruent. So are the triangles congruent? Yes, because all corresponding sides and angles are congruent. Let's go over this try now together. Can we conclude that triangle JKL is congruent to triangle MNL? Justify your answer. Notice in the picture that we actually have we have angle J and angle M are congruent, and we have angle K and angle N congruent because they're marked congruent. Now I can also add markings right here for angle L because those 2 angles, as we know, are vertical angles, and vertical angles are congruent. But now let's look at the sides. Side JL has 1 tick mark here. JL should match with ML. But notice how ML has 2 tick marks. So if they were congruent, they would have to be marked the same, but that has 1 mark. That has 2 marks, so they are not congruent. So our angles are good, but the sides do not match up. So these 2 triangles, we cannot conclude they're congruent because the corresponding sides are not congruent. Right? I know they're not congruent because JL has 1 tick mark, and ML has 2 tick marks. If they were congruent, they would need to be marked the same, and they're not. For our next example, we're going to use congruent corresponding parts to solve for some different things. First, we want to find the value of x, and notice that the x is marked right here. So the x is marked with angle C right here. And according to our diagram, or our congruent statement, angle C should be congruent to angle C because they are in the same spot in the congruence statement, right? So angle C should be congruent to angle C. Well, notice that this one's marked with 90, so that tells me that the other one must be 90 as well. So we're going to solve 2x minus 16 equals 90. And now it's just an algebra equation. We'll add 16 on each side. So 2x equals 106. And then we'll divide each side by 2 to get x equals 53. All right, next up, we want to find the measure of angle DBC. In our diagram, DBC is this angle right there. Now, we currently know in this triangle, we know that angle C there is 90 degrees because it's marked with the right angle box. And we could actually figure out what angle D is using the fact that angle D has to be congruent to angle A. And notice in the diagram that angle A is 49.3. That means D must also be 49.3 degrees. Well, now if we draw our attention to this triangle over here, we have 2 out of the 3 angles. Remember that the 3 angles in a triangle will always add to 180. So if I go 90 plus 49.3 plus the measure of angle DBC, that's the one that we're trying to find right here, that has to add to 180. Well, let's add together the 2 that we know. 90 plus 49.3 is 139.3. And then we can subtract that from 180 to get the remaining angle. So stick that in your calculator and it would be 40.7 degrees. So there is our answer for part B. The measure of angle DBC is 40.7 degrees. To double check now, if you add together these 3 numbers, 40.7 plus 49.3 plus 90 adds to 180. For our final example, we're going to prove that the 2 triangles here are congruent. So we're given that CG is congruent to DG. That's the first given. And then we're also given that CN is congruent to DN. The way this proof is set up is it just broke the givens up into separate lines. You can do it that way. Or you can put them all on one line. It's just a preference. I think here it's just kind of nice because then we can match up all of the corresponding parts. And then for my third side, this is not part of the given, but notice that GN is in both of the triangles, and GN is congruent to itself by the reflexive property. That is one of your properties from Unit 1. The reflexive property of congruence says that something is congruent to itself. So now we've covered all of the sides. Let's see if we have angles that are congruent. Angle C congruent to angle D is part of the given. And then for the next one, angle CNG is this right angle, and that's congruent to angle DNG, and that's just because all right angles are congruent. Okay, and then we need one more angle, and for that angle, that's going to be this one up here. Well, we've shown that 2 angles of one triangle are congruent to 2 angles of another triangle, so we know that the third angles must also be congruent. Here, I'm going to name them with 3 letters. That's angle CGN is congruent to angle DGN, and that is by the third angles theorem. So now I've shown that we have 3 pairs of congruent sides and 3 pairs of congruent angles. So that tells us that triangle CNG is congruent to triangle DNG by definition of congruent triangles.